is the Chapter 6, Lessons 1 and 2 video on random variables and types. We're going to look at discrete and continuous. So first, let's look at our guiding question. So what is a random variable? How are discrete random variables different from continuous random variables? So discrete means a fixed set of values. So if I'm counting the number of shots I made playing basketball, I can't make 1.2. I can't make 7.5 shots. I'm counting the number of students in a class. There's no 2.5 students. It's only whole numbers. So discrete has a fixed set of values. An example, it's not just whole numbers, would be shoe size. You could have a 5, a 5.5, a 6. So it's not always just whole numbers, but there's fixed values, and you can't have values in between those. So you can't have a shoe size of 6.49. You're a 6.5 or you're a 6. A continuous variable takes on all values in an interval. So measuring the length of your foot would be an example of a continuous variable. So then that's important to remember as we get started with this. That will change possible outcomes. A probability distribution. We've looked at a lot of probability. We've looked at some of these in the previous chapter. It gives all possible values of a random variable and their probabilities. It's the kind of same deal that we looked at in the last chapter and in chapter 1, how often a variable takes on certain values or the likelihood that it'll take on certain values in the long run. So we'll have values and the probability that they occur. And we can use that to have an expected value, or the average, you could think of our probability distribution. So we want to look at shape, center, and spread of the probability distribution. The center, we're usually going to use the expected value. That'd be the average of the variable, which is like a weighted average. It's computed much in the same way your grade for this class is computed, where there's a percentage of the grade times a score. So if tests are worth 50%, it's 0.5 times your overall average for tests. And you add up all the different percentages times the score you have there to get your overall grade. The shape would be looking at height of each bar and the probability of that outcome, and any general shape pattern we notice. The spread, the standard deviation of the random variable is what we're going to tend to use because we use the expected value, which is like the average. So those are going to be how we describe a probability distribution: shape, center, and spread. When we look at a density curve, including the normal distribution, we can find the probability by finding the area under the curve and above the values of interest. So if the probability of x is greater than or equal to 1 equals 7/8, that means about 87.5% of the time in the long run we'd expect to get one or more heads for flipping 3 coins. And that would be represented by the area, including 1, but below the density curve above the x-axis. So a probability distribution will oftentimes look like this: x representing the different values in the distribution, p representing the probability of this first value, the probability of the second value, the probability of the third. So the sum of the probabilities down here must always equal 1. No individual probability can be less than 0 or greater than 1 itself, so negative probabilities don't exist. So the values have to be between 0 and 1. They have to sum to 1. And then the expected value is the value times the probability it occurs, plus the second value times the probability it occurs, plus the third value times the probability it occurs, which is represented down here. Now the variance would be the distance of each point from that expected value. So here our average is the expected value. So you take the first point and see how far is it from the mean. Square it, then multiply it by the probability. Do the same thing for the second and third points, so on. Once we have that, we would take the square root to find the standard deviation, or the average distance of our probability distribution from the expected value. So much of this is the same as we've gone over already. It's just a new application in terms of probability. Since a continuous variable takes on an infinite number of values in an interval, because there's an infinite amount of values between 1 and 2, meaning you could have 1.0000001. You could go on like that forever, and you could spend the rest of your life writing down numbers between 1 and 2 with never writing down all the numbers. So essentially the probability of each outcome is 0 because there's an infinite number of outcomes. So when we're looking at continuous random variables, we're looking at the probability that a value lies within a range of values, since there's an infinite amount of numbers between 0.3 and 0.7. So we'll always be talking about, with continuous variables, values that don't have to have specific values, that can take on a range of values in an interval. We'll look at the probability that it lies within an interval. Now would be a good time to look over the summary from 6.1 and some of the examples in the book as you pause. We're going to jump into 6.2 here. We're transforming and combining variables, which is very similar to what we did in transforming and combining distributions earlier in the year, where we added and subtracted or multiplied and divided, and how it affects shape, center, and spread. So some examples of questions we'll answer here is there a significant difference in the mean salaries for men and women in a certain industry? Do patients taking a new drug have a higher survival rate than those taking the currently used drugs? So this is a nice refresher of what we went over earlier in the semester, that adding and subtracting a constant, that means a number that stays the same, adds that same value to measures of center and location. So meaning the expected value would be added that if you added it to the whole distribution. And location, so percentiles, quartiles, and medians. It doesn't change the spread, because remember, adding and subtracting is like adding a negative number, just shifts the entire distribution one way. So the amount of spread, it doesn't get more stretched out or more squished. It stays just as spread out as before. So it doesn't change range, IQR, or standard deviation. Whereas multiplying, remember, dividing is like multiplying by 1 over a number, so the same thing applies there, by a constant b. Multiplies or divides each observation by a constant b. So that means every value is multiplied. Because of that, you're spreading it out more if you're multiplying by a number over 1. If you're multiplying by a number less than 1, which would be like dividing by a number bigger than 1, you would be making the spread less, so bringing the distribution closer together. However, neither of these ever change the shape. So adding and subtracting changes measures of center and location. Multiplying and dividing changes measures of center and location, as well as measures of spread. Neither one changes the shape of a distribution. So down here we have an example of a linear transformation where we're multiplying and adding. And this is just an example to pause and look over what happens when we do both. So pay close attention here. We're going to go through an example of expected value, and you're going to have a similar multiple choice question where you're going to show your work in a similar fashion. So here's our probability distribution, the values it can take, how likely each of those are, and then to find the expected value, we multiply the value itself times the probability it occurs, plus the second value times its probability, and so on until we go through all of the possible outcomes. So here, this is the number of passengers expected on this Jeep tour. We're saying there's a 15% chance that 2 come, 25% chance that 3 come. So this is like a weighted average. That's another way to think about expected value. So when we add those all up, we end up with, we expect 3.75 passengers, or about 3 3/4. Since it's a discrete value, we'd want to interpret that by saying about 4, since you can't have 3 3/4 people. To find the variance, you're going to go ahead and subtract that value that we got, the expected value, from each of these here. So the only thing that changes here is now you're subtracting the expected value and squaring it times the likelihood it would occur. Doing that for the second value. So notice each of these is subtracting 3.75, the expected value, squaring it, adding all those up. So we get 1.1875 as the variance. Standard deviation is always the square root of variance, or the average distance from the expected value is what that tells us if we're interpreting it. So on average, our values are 1.09 above and below the mean, or the expected value of 3.75. So pause that, take a look over it so you get a good idea of how to calculate variance and standard deviation. Independent random variables. Just like we looked at independence in Chapter 5, if a random variable is, if 2 random variables are independent, that means an event involving one of them, we'll call x. That occurring tells us nothing about the occurrence of a second event, meaning one event occurring doesn't change the likelihood of a second event. So we've discussed that. It's going to continue to be a big issue, so make sure you see me if you need help with independence and mutually exclusive. Okay, here's your multiple choice question. I misspoke, your free response question. So here's a probability distribution. I would like you to find the expected value the variance, and the standard deviation, just like I did above. So show the work as I did before by just writing out the terms that got you to that answer. So go ahead and pause this, calculate that, and submit your answer. Type up your answer for the free response question now. So the last couple of things in 6.2 are we're looking at two independent random variables. If we combine two random variables, the key thing to remember here is more variables, more variance. It doesn't matter if we subtract the two, like we're looking at the difference in average salaries between men and women, or we add them, whether we're combining two random variables in their occurrence. The more variables we have, the more variance, so the more things will vary from the mean or the expected value. So more variables, more variance. Say that to yourself right now. That is a common thing that students confuse. So even with subtracting two random variables, the variances add. And remember, the variances add, standard deviations don't. So when we want to find the standard deviation of the new data set, we'd have to square the two standard deviations of the data sets on their own, add them up, and then take the square root of that in order to find the standard deviation of once we've added the two random variables or subtracted. Okay, so review what I just said in the video, go over the lesson 6.2 in your book and look over the examples, and then answer this multiple choice question about expected value once we combine two variables.